Hello everybody, my name is Soldevilla,
And I am in Cardona.
and today we are excited to talk about our final project for IE4314. We're going to be going over the S&P 500 stock market forecasting using machine learning and deep learning. This project explores how well different machine learning models can predict the stock market trends, specifically focusing on the SP 500 index.
Our goal was to build models that could do two things: predict whether the stock market will go up or down tomorrow, our classification problem, and predict the exact closing price for the next day, our regression problem. We used both traditional machine learning methods and more advanced deep learning techniques to compare how well they work with stock market data.
In this project, we had three main objectives. The first was to evaluate how machine learning and deep learning models could perform in forecasting the S&P 500. The second objective that we had was to compare simpler models like logistic regression to more advanced models like the LSTMs that we have in our project. The third objective that we had was to simulate real-world predictions using a technique using rolling forecasting, where the model updates its input data daily before making the next prediction. While researching for this project, we based a lot of our approaches on several key studies that we looked over. So, for example, the first one we kind of looked over was a 2023 study that compared the XG boost versus the linear regression, which showed that the XG boost really outperformed the linear regression in order to be able to predict better stock trends overall. So that kind of gave us the idea to look into neural networks. So that kind of showed us to our next study, which was conducted in 2020, that talks about LSTMs, which is short for long short-term memory. It is a form of neural networks, and they conducted this study on stock trends as well, and they showed that these models could actually perform very well in being able to predict what the stock market would actually do. Which leads us to our third technical paper that we researched that was conducted in 2024, which compared the LSTM models to the ARIMA models, which are statistical models used mostly for finance situations. And it showed that LSTM models were actually giving more accurate results compared to this other model. So basing it off of that, we could see that the LSTM models would perform a little bit better. And coming to our last study that we researched was an article published in 2022 that went over multivariate LSTMs, which measured for volatility. And this study actually showed that when using multiple indicators to be able to predict the stock market changes, using those multiple indicators, it was more accurately able to predict what the stock market was actually going to do.
We use historically daily S&P 500 data from 1927 to 2023, which includes open, high, low, close, and volume values. We added new features to improve model accuracy as well. We included next day close, daily return, a binary target for classification, technical indicators like SMA, RSI, MACD, momentum, and Bollinger Bands. These indicators are widely used by traders and help capture trends and volatility.
When conducting our project, we used visual tools to better understand our data. These included a correlation heat map to show how features are related to one another. We also used ROC curves to evaluate classification performance. We also did Confucius matrices. That way we could actually understand what our classification data was actually doing. And then lastly, we also made actual versus predictive graphs to check how close our regression models were to the actual data set. These visuals helped us choose features to evaluate how well our models performed.
As you can see here, we have the feature correlation heat map. It is comparing all the different sets that the data includes. As we can see on the legend on the right hand side, blue being that there is no correlation to it, meaning it's not linearly related, and red as it moves on to the red side, meaning it is very has a high correlation or it is very connected linearly.
When we were conducting this project, we looked into three different types of models. First, we looked at our classification models. These uses more of a binary system to be able to make predictions. For our models, we decided to go with logistic regression, the k nearest neighbors or KNN, and we also went with random forest. For our regression models, we went ahead and went with our linear regression, our KNN regressor, and also a random forest regressor. And lastly, for our deep learning models that we used for this project, we decided to go with multiple LSTM models, which included a univariate model, a multivariate model, a rolling forecast model, and also a sequence to sequence LSTM model. Each model has different strengths and weaknesses, and we tested how they performed on the same data set and then compared them to each other.
For our innovative methods, one innovation in our project was the use of rolling forecasting with LSTM. Instead of training once and testing in a batch, the model predicts one day, then updates using the real results before predicting the next. This mirrors how a model would work in real trading. We also used hyperparameter tuning like Grid Search CV to improve our machine learning models by testing different settings.
So the way we wanted to evaluate our models were based on three categories. So we had our classification metrics, which included how accurate those results came out, how precise each model was going to be, the recall value, the F1 value, and the AUC values of each classification model. For our regression models, we used the metrics that were the MSE, the MAE, and we also used R squared to see if our models were actually uh, performing well. And the way we conducted all these tests was having a chronological train split model where we would train 80% of the data and use the other 20% to actually test the models themselves. So with our classification results, we're able to see that our models didn't really perform to the way we wanted to. So our logistical regression model was by far our best classification model that we had. And this model was only around 51% accurate, so only a little bit better than flipping a coin. Our KNN models and also our random forest model were very low performing, and their accuracy wasn't very good. It was below the 50% mark. And later on, we will see the ROC curves. That way, you could see how these models actually performed. So taking a look at our confusion matrices for all three classification models, we see that whenever our logistic regression model, whenever it was able to predict, our model was able to predict that the price was going to go up, the actual model performed did go up. So it was able to do that 1,534 times. But looking at all the other squares, it looks like the model didn't really perform that differently compared. So it is really hard to decide if our this would be the best approach to see if the stock market was actually going to go up in price or down in price. And on the top right corner, you can see our ROC graph and chart. And you can see how all our models perform basically the same way, with being right along the ROC dotted line, which means that, like I've said before, it is no different than flipping a coin to see if the stock market price would go up or down.
For our regression results, we ran different models. We went through all the different linear regression models, the univariate LSTM, the multivariate LSTM, the rolling LSTM, and the sequence to sequence LSTM models. And we will be going through all the different values in the coming graphs. For a linear regression graph, we got a R-square value of 99.95, as well as the 18.5 error. This is going to be our too perfect model. We will not be considering it as it is too accurate. Next up, we'll be talking about our univariate LSTM model. This one ended up coming off with an R-square value of 0.9862 with an error of 117. We will not be considering this one as the error is too great. Our multivariate LSTM model with an R-square value of 0.9922 and an error of 66.2. This is going to be the model that we will be selecting, as it is just the right amount of accurate and the error is not too great. For a rolling forecast model, the R-square value of it was 0.9832, which is a very good accuracy, and our error margin is going to be 96.6, which again is too greater, as the previous multivariate had a lower error margin. For a sequence to sequence model, the R-square value was calculated to be 0.8999, repeating, and an error of 222.2. We will also not be considering this one as it has the biggest margin of error for the closing prices.
So after taking a look at all the models that we made for this project, we found that deep learning models, especially the LSTM models, are excellent at predicting prices. But the classification models weren't really that good at predicting if the market was going to go up or down, which makes the models not good to use for this situation. That's likely because the market is influenced by many factors that are not in our data set, as political issues may occur all around the world and other situations as well.
For future improvements, we have a few steps we could take with our models. First off, we'll be adding real-time news segments or economic indicators that could be affecting the stock market, as well as testing newer models like transformers or attention mechanisms as well, and using ensemble methods or hybrid models, as well as real-time retraining and continuous evaluation that combine machine learning and deep learning.
So, to conclude our presentation, we learned three important things throughout this project. First thing that we learned was that LSTM models are very effective for financial forecasting, as deep learning works very well to be able to predict future prices. The second thing we learned was that classification remains challenging without more complex data. Our classification models didn't perform very good during this project, so having more data to help these models would be very beneficial. And the last thing we learned on this project was that our project shows that machine learning can support financial forecasting, but it has its limits. And a thoughtful model design and validation for these models are very crucial.
We would also like to give special thanks to Dr. Wang, who has been our professor in this IE4314 data mining and analytics at the University of Texas. We appreciate his help as well as his insights on our project, and we have included here our references. We thank you all for your time, and I hope you guys have a great day.